Okay, so today we'll be discussing communication and internet technologies. First of all, communication. So, what is communication? It is simply the transmission or sharing of data between two or more devices. Say a computer or a printer, which would be like short distance transmission because they're normally within, a couple of feet of each other, or quite often connected by a cable. So that is short distance. Or you can say a telephone network to a phone. So whenever you send some kind of message or you're calling someone, that like the connection goes to the telephone network and then to the other person's phone. So if you're talking to someone on the other side of the world, that is essentially long distance data transmission. So that's basically, you can think of it as two types of data transmission based on how much distance the data has to travel. So that's the general idea. Now, whenever we're considering communication of data, there are three main factors we need to see when we're sort of analyzing how we communicate or share data. Right. First of that is direction of the data. So basically, imagine you have a network where there are two devices, all right, and within those devices, one of them is the sender and the other is the receiver. So that is essentially unidirectional data transmission. Or it could be it could be that both of the devices can send and receive data, so that would be bidirectional. So that is what we mean by direction of data. When we come to method of transmission of data, we are basically saying how many bits, or essentially how much data is being transferred at the same time. And then coming to the last one, method of synchronizing. So we can, as of now, just understand that it is asynchronous or synchronous. We'll delve into this deeply later on. So okay, coming to direction of data. So like I said, there could be a system where only one device is the sender and one is the receiver. So that is simplex data transmission or one direction. So essentially, imagine your computer and your printer. Your computer is the only device in that network of the computer and printer that can send data. The job of the printer is only to receive data, and it cannot send any kind of data back. Similarly, see your keyboard in your computer. When you type something, your keyboard is sending the data to your computer, but the computer cannot send back any data to the keyboard. So that is simplex data transmission or one direction data transmission. Coming to half duplex data transmission. So in simplex, one device simply cannot communicate, cannot send, and it only receives. But the thing with half duplex is both the devices can send and receive data, but they can't do it at the same time. So what that means is, say you're using a walkie talkie, so you will have to first wait for the other person to finish sending the data, finish speaking. Only then can you start sending data yourself. Both of you cannot send the data at the same time. That is what half duplex data transmission means. Full duplex data transmission is also called simply duplex data transmission. And what that means is that data can be sent from both the devices. Essentially, we're simply considering two device networks in this case. So two directions, all right. So both of the devices can send the data at the same time. So imagine you're using some kind of messaging app, all right. So you don't have to wait for the other person to finish sending what they're typing or writing or whatever they want to communicate before you send your own data. That is what we mean by duplex data transmission, because both of you can simultaneously send data. So basically, those were the types of data transmission when it comes to direction of data. Now, method of transmission of data. So we discussed that this was how much data or how many bits are being sent at the same time. So for this, we have two types. We have serial transmissions and parallel transmissions. So serial transmission is when one bit is transferred over a single wire at a particular time. And we prefer this for long distance transmission of data, because whenever, say, let me just discuss parallel transmissions, then I'll explain why this works. So it just understand that it's preferred for long distance transmission. For parallel transmissions, what we understand is that multiple bits of data are being sent at the same time, but it's being sent over different wires. So what that means is, if you're sending 8 bits of data or a byte of data, you're sending it over 8 separate wires, but all at the same time. All right. Now we prefer this for short distance transmission of data. Now coming to why. So the thing with serial transmissions is that since you're sending data one after the other, you know the order of data is less likely to get mixed up, and your data will stay safe over a long distance because you know you're using only one single wire. When you're using parallel transmissions, you're using multiple wires, and you're sending data all together at the same time. So there is a chance that your data can get skewed or changed when you're sending so much of data, and especially if you're sending it to a very, very far away place. So if it's some kind of long distance transmission, we prefer sending the data one after the other instead of all together, just to ensure that there is no misinterpretation of data because there's so much data all at the same time. Parallel transmission is definitely faster, and for short distance it's faster because you're sending multiple bits of data all together. So that is why we prefer it for short distance, where there is a less chance of the data getting mixed up, and it's much faster. So that's why it's preferred for short distance. But for long distance, if you have to keep your data safe, we generally work with serial transmissions. Now, method of synchronization of devices. So as I said, it was asynchronous and synchronous. So what this means is that when you're sending data in asynchronous data transmission, the data is transferred in certain packets. So the packet size is normally 1 byte. So every data packet is sent with control bits. What these control bits do is they tell the receiver when the data begins and when it ends. All right. So the thing that you need to understand for this is basically that whenever you're sending some kind of data to the receiver needs to know how to interpret the data, all right? And that is what these control bits will be telling the receiver. So it just prevents the data packets from getting mixed up. And whenever we're sending these data packets, they have a time interval between them, and it's not fixed, all right? So this time interval is very uneven. But again, we can understand that the general idea with asynchronous is we're sending it as separate discrete packets, and that is how it contrasts with synchronous data transmission, where we're sending the data as a continuous stream. So we're not stopping, we're not waiting, we're just simply sending the data. So now the question arises that how are we supposed to ensure the sender and receiver are on the same page? How are they supposed to interpret the data, because we're not sending any control bits, we're not waiting for any period of time. And if the receiver or the sender is even slightly off, the data can be misinterpreted quite drastically, all right? So the way we prevent that is we use timing signals. Now, these timing signals are generated by an internal clock, and these signals basically make sure that the sender and receiver are in step with each other. What that means is that the sender and receiver are both calibrated in the same way, so that when the receiver gets the data, it is able to understand how it should be interpreted. All right. So the receiver basically will count the number of bits sent in a period of time, and then it reassembles them into bytes. All right, so these timings definitely have to be very, very accurate because we don't have any control bytes. Control bits. So that's why, since these timing signals are what we use to ensure that the data is correctly understood, this has to be very, very precise, especially since you can imagine the scale at which data is being transferred. It is instantaneous, right? And in that, even the slightest bit of time delay will cause quite a bit of issues. So it has to be extremely, extremely accurate. Now, definitely asynchronous is slower than synchronous, because when you're sending a continuous stream of data, you can simply finish up sending the data much, much faster than, say, you're sending a packet and then you're waiting and then you're sending the next packet. That's definitely slower than synchronous data transmission. All right, so now we come to universal serial bus. So we've seen what asynchronous form of data transmission is, that we send a bit of data, then we wait, and then we send the next packet. So USBs, I'm sure all of you must have used it at some point in time. So that basically uses asynchronous form of data transmission. So a USB has 4 cables inside it. 2 are for power and earth, essentially 1 for power, 1 for earth, and 2 are for the transmission of data. So whenever I assume that every laptop has a USB port, and you can essentially attach a device to the computer using that USB port. So how the computer detects a device is basically a change in voltage. So computers are electronic devices, they can detect changes in voltage. So that's how you detect a device. Now, whenever you're say connecting a new device to your computer, say you just brought a new printer and you want to use your printer with your laptop, so the first thing you need to do is you need to install a device driver. A device driver is essentially a software which makes it easy for your computer to communicate with the different hardware, right? Because imagine a computer manufacturer, all right? Now that person cannot know exactly what kind of devices your computer or you might want to interact with. So it is very difficult for them to ensure compatibility with every single different type of device. That is why softwares like device drivers are made to essentially make sure that your device is compatible with whatever other device that needs to be used. All right, so a computer must have the device driver installed for the device being attached. All right, otherwise it is very difficult for the computer to communicate with the device, as you can understand. So after the device is set up, after all the device driver installation is over, that USB cable can be used for data transmission. So again, I'm going to use the printer example because I believe it is very common. And imagine that you're using your printer. So normally what you do is you put in a wire into your laptop and you send your data from your computer to the printer using that wire. So that wire generally attaches in the USB port, and this is a very practical, simple example you can see of data transmission. All right.